Suppose now we have the second condition or second type of figure, that the dielectric is perpendicular to the capacitor, right? The dielectric is perpendicularly filled here, right? So here there are two types of capacitors, K1 and K2. So here I will draw the equivalent as like this, right? So this becomes C1 and this becomes C2. This is having dielectric constant K1, this is having K2, right? What happens here? Here the distance is not half, the area of the plate is halved, right? So here again C1 will become K1 A epsilon naught, right? But here in place of A you are supposed to write A by 2 divided by D, or I can write K A epsilon naught by 2D, right? K1. What will be C2? C K2 A epsilon naught by 2D, that is A by 2 here. Now C1 and C2 are connected in parallel. In parallel means you just add those guys. So C equivalent is C1 plus C2. So it will be added as K1 A epsilon naught by 2D plus K2 A epsilon naught by 2D. When you add these two guys, it becomes A epsilon naught by 2D is common into K1 plus K2. Clear? Right. Now you guys can do the problems where you mix up the conditions also, if you understood the logic of it. So when the dielectric is filled parallel, right, like this, when you, it seems like parallel like this, if you are feeling like this, right, then these are looking like series connection. There is two, right? In this connection the capacitors are in parallel, in this condition it is in series. I hope this much is clear. Right. I want to add something, guys. Suppose you are having capacitor, you keep a metal plate inside it. What happens? What happens to its capacitance? You know Cm is equal to K into C, right? So whenever you induce a medium, the capacitance increases. Whereas in the metal plate or a conductor, K is infinity. So what becomes of the capacitance? Capacitance also increases to infinity. So when you indirectly or directly put a metal plate or a very good conductor between a parallel plate capacitor, its capacitance increases or it goes to infinity. The next type of question which you have to deal is Wheatstone's bridge, second part, that is, suppose the Wheatstone's bridge is not balanced, right? This what the condition was initially, you remember, this was Wheatstone's bridge, right? Suppose this is 1, okay, this is right, this is 1, this is 2, but this is 2 and 1. Ratio are supposed to be like this, 1 by 2 should be equal to 1 by 2, like this. That is, this was C1, C2, C3 and C4. C1 by C2 should be equal to C3 by C4. But does this show the same value? This is 1, this is 2. So 1 by 2 is equal to 2 by 1. Is it? No. 1 by 2 is not equal to 2 by 1. So this circuit is not balanced. So what would I do when this type of circuits come? Guys, I am telling this type of problems, this is never mentioned in your textbook, and I don't think you will see in some of the entrance question book also, because now I am going to actually cover the topic, the same topic which is covered in BSc physics or in engineering physics. Right, let's move on. So there is a concept called star delta method, right? This conversion of star to delta method. Star means if the components are connected in this way, right? Star, this is star, and delta is in this way, triangular shape. I hope you understood what is the shape difference. This is a star connection, this is a delta connection, right? So how many, do you see a star connection here? Yes, there is a star connection. You can bend these connections, okay? You can rotate whatever. This looks like a star, that is from one point there are 3 terminals, so this is star. Delta, because it is like a triangular shape. This much clear? Now before moving to this topic, we'll understand how to convert a star connection or how to redraw a star connection into delta. Suppose I name these capacitors CA, this is CB, this is CC, right? So I want to convert this into this form. So how can I place this in here? I can redraw like this, right? I'm going to write it as a dot, right? right? Did this star become delta? Yes, this star became a delta here. This is this edge, this is this edge, and this is this edge. This much is clear. Now let this be C1, this be C2, and this be C3. Right. So this is C1, this is C2, this is C3. Right. I will make with another pen so that you guys are not confused. I will make it with another pen. Right. So this is C2, C3, C1. Clear? So C1 is the equivalent for CA and CB, C3 is equivalent for CB and CC, and C2 is equivalent for CA and CC. Guys, just understand or by heart the law, know how to write the equation. The derivation is a very big thing or a very long process. You need not by heart those entire thing. You just require a short trick for solving the problems. Clear? So this, how can I find C1? Now C1, that is this C1's equation, you can generate very easily. C1 is between CA and CB, right? So it is C1 is equal to CA into CB whole divided by all the resistance or capacitance, that is CA plus CB plus CC. Easy? Right. Now so what will be CBB? Can you write now? C2B. C2 is between CA and CC. So C2 is CA into CC divided by CA plus CB plus CC. Right, you need not by heart it. Similarly, so what is C3? It is between CB and CC. That is CB into CC divided by CA plus CB plus CC. Guys, these are all neat topics, guys. I'm taking this because sometimes in our last year many neat questions were asked in CBSE book exam, so we have to learn these criteria. Now you have C1, C2 and C3, right? This is how you convert a star connection to delta connection, right? This much is clear. Now we will go for the Wheatstone's bridge. Now this was your Wheatstone's bridge, right? Let's put some values. You have already values. How can I redraw this diagram? Can I redraw this diagram? Right, I can redraw this diagram. How can I redraw? Let's see. This becomes, right, like this. These two are parallel, right? So this is 1, this is 2, then like this, then this like this, right? The same figure, right? And this is 1 microfarad, this is 2 microfarad, this is 2 microfarad, and this is how much? 1 microfarad. Suppose the middle one is 3 microfarad. I will write the earlier section. So this is the redrawn version of the above Wheatstone's bridge. It's okay, right? I hope you understood. You can draw it like this. You can draw in whichever way you want, but it should be correct, right? Now what do you see a star connection? You see a star connection here, right? This is a star connection. I want to make the star connection into delta, right? So how am I going to make, right? Now it became a delta. See, I modeled it in a this wedge came because the equation is written over here. Sorry guys. So this is a delta conversion, right? So what will be this value? Suppose you make it a C1, this is C2, this is C3. So we'll put the values here. So what is C1? Let's see. C1 is between 1 and 2. So C1 is 1 into 2 whole divided by 3, guys. That is 1 plus 2 plus 3 is 6. That is 1 by 3 microfarad, right? So what is C2? C2 is between 1 and 3. So it is 1 into 3 divided by whole, guys. That is 6. That is 3 by 6 microfarad, or I can write 9 by 2 microfarad. Right. So what is C3? C3 is between 3 and 2. So it is 3 into 2 divided by 6. That is that is becomes 1 microfarad, right? So I'm going to redraw the circuit again, guys, with the delta. Now you are having a terminal A, these three works off, right? In place of them you have a C1, right? Then you have C2, then you have C3, right? I hope it is clear. Then this much portion is over, and then you have a 2 microfarad here, right? And then you have a 2 microfarad here. The circuit is completed. Sorry. This is the computer, and this is 1 by 3. This C2, this is 1 by 2, and this is how much? 1. Right. These values has been substituted. This is 2 microfarad and this is 1 microfarad. Now you can solve this easily. These two capacitors are in parallel, and these two capacitors are in series, right? Okay, sorry, again are in parallel. How would you solve it? Now this is A, right? Let's move on this, let it be 1 by 3 itself. When these are in parallel, you add them. 1 by 2 plus 2 is how much? This much you have to calculate by yourself, okay? How would I put? I will write like this. 1 by 2 plus 2, 4, 5 by 2. So it is 5 by 2. Right, here 1 and 1 at parallel. Again it will be 2 microfarad. Right, now 5 by 2 and 2 microfarad are in series, right? So when series, you will do a reciprocal, or you will write C1 C2 divided by C1 plus C2. So it will be 5 by 2 into 2 divided by 5 by 2 plus 2, right? So 5 divided by that becomes 4, 9 by 2, so it is 10 by 9 microfarad, right? So redraw the figure again. So it will be 1 by 3 here and 10 by 9 here, and they are in parallel, so you add them. 1 by 3 plus 10 by 9 is 3 plus, right, the 3 into 3, so it becomes 3 plus 10, that is 13 by 9 microfarad. That is your answer. These are not calculations I am doing first, because calculations has to be done by you. I am just indicating how the circuit can be solved, right? Now I will give you a short trick. See, suppose you are doing neat questions, this and all calculation takes a lots of time. So I'll give you a short equation for solving this. Is CAB. If you are able to remember this equation, good. CAB, that is whenever you are having a Weissen's bridge in an unbalanced way, is the equivalent capacitance is C1 plus C2 into C3 C4 plus C3 plus C4 into C1 C2 plus C5 into C1 plus C2 into C3 plus C4, whole divided by C5 C1 plus C2 plus C3 plus C4 plus C1 plus C3 into C2 plus C4. Guys, I will never prefer you by hearting this equation, because something will be going off. It's better if you are able to solve it by the star delta method. I hope you understood. You are having a star conversion or star point, you just have to convert it into delta, then you will get a circuit which you can easily solve by yourself. This much is clear.